Hello there, this is an Algebra 2 video. It is Chapter 7, Section 6, and today we're going to be discussing common logarithms. And this might be good news for you because thus far you've not necessarily been able to plug logarithms into your calculator because your calculator only runs in a base 10 and a base E for logarithms. So whenever you've had log base 2 or log base 4, you weren't able to plug it into your calculator. You had to do it in your head. So one thing I wanted to make a point of is that when you have log base 10 or the common log, which is the base 10 logarithm, you don't have to explicitly write 10. Just like when you have a square root, you don't write the little 2 for a square root, or x to the, when you have like 5x, you don't x to the 1 power, you don't actually write the little 1. Same is true here. You can put a base 10 there, but you don't have to. And so basically what I want to be sure I tell you is that anytime the base is not explicitly written, then you are to assume that it's a base 10. Okay? So it says here, use the calculator to evaluate each expression to the nearest 10,000. Log base 10 of 5 equals question mark, remember? And so if you remember, we want to know 10 to what power is 5? That's the question. But in this case, because 5 is not a perfect power of 10, it's going to be some kind of a decimal. So what you want to do is just go to your calculator and hit the log button, which is immediately to the left of the number 7 on your keypad. And when you do that, an automatic parenthesis will open up. And then you want to type in 5, close that parenthesis, hit enter, and you should get approximately 0.6989. So it keeps on going on. But it says it wants us to go to the nearest 10,000. So this is the tenths, hundredths, this is the thousandths. And so 10,000ths would be 6990. Because we get 69897, so we only want 4 decimal places, but this 7 is going to make this a 0, so we're actually going to end up with 6990 for our answer. But more importantly, I kind of want to show you what is happening here is that according to this exponential form, it means that if I take 10 and raise it to the 0.6990 power, I should get 5 or something very, very close to it. And so you can check that. You can go 10 raised to the power of 0.6990, and you in fact get 5.0003. So basically, that's how logarithms work with exponentials. They're inverses, right? So just want to remind you about that. This again is saying 10 to what power is equal to 0.3. And again, we can use our log button on our calculator and type 0.3, and we get that it's going to be negative 0.5229. And again, if I take the 10 and raise it to the negative 0.5229 power, I get 0.29999, which is basically really close to 0.3. So these are our answers, negative 0.5229 and 0.6990. So now you can do these two do-it-yourself questions. It won't take you very long. And then we're going to move on to this example here. It says the loudness L in decibels of a sound is L equals 10 log I over M, where I is the intensity of the sound and M is the minimum intensity of sound detectable by the human ear. Residents living several miles from a concert venue can hear the music at an intensity of 66.6, that's a scary number, they got 3 6s there, but we're just going to move on. 66.6 decibels. How many times the minimum intensity of sound detectable by the human ear was this sound, if M is defined to be 1? So what we want to do is, we know that the loudness was heard at 66.6 decibels. That's our L value, L in decibels. So 66.6 is going to replace the L in our equation. And then we're going to have 10 log of the intensity is what we're looking for if M is defined to be 1 according to the last portion of the example there. So now all we get is we want to basically divide both sides. We don't need this one here anymore, but we divide by 10 on both sides, which gives us 6.66. That's just a matter of moving the decimal place right 1 unit over. So 6.66, and these 10s cancel, so now you have log I. And again, it doesn't explicitly have a base, And when it doesn't explicitly have a base, we assume that it is a base 10. So what this is asking us is 10 to the 6.66 power. Remember that we can take the logarithmic form and write it in exponential form. So it's telling us that 10 to the 6.66 power is equal to I. So all I need to do is go 10 to the 6.66 power, and I'm going to get that I is equal to, or approximately equal to, I should say, 4, 5, 7, 0, 8, 8, 1.9. Alrighty? So basically, 4,570,882 decibels. The sound heard by the residents was approximately that much times the minimum intensity of sound detectable by the human ear. That's crazy. Okay? That's a lot. So now if you will try this example, we'll go on to number 3, example 3 here. It says solve 4 to the x equals 19, round to the nearest 10,000. So again, when you have an exponential form, it makes sense for us to use logarithms to solve them because it is the inverse of the exponential. So what I want to do is I'm going to use a base 10, and I'm going to take the log of both sides. So I'm going to rewrite it, so I'm going to say log of 4 to the x equals log of 19. So I'm taking the log of both sides. When I do that, I can apply the property of the power to a power here, 4 to the x. So we know that when that happens, according to the previous lesson, the x comes in front. And that's what I need. I need the x kind of be out of the exponent so I can actually solve for it. So I get x times log 4 equals log 19. And now because this is x times log 4, I can divide by log 4 on both sides. And so x is equal to exactly equal to log 19 divided by log 4. Now don't confuse this with the property that says that you can take a quotient and make it a subtraction. You could do that if it was log 19 over 4, but it's not log 19 over 4, it's log 19 over log 4. So again, that would be if you had log 19 over 4, then you can convert that to subtraction. This is not what that is. You have a log on each piece of the fraction there. So this is not what you want to do. Just want to remind you that you can't do that. So this is our exact answer, but what you can do is because they don't have a base, we assume that it's a base 10, and you can put that in your calculator. So we're going to go log of 19, close parentheses, and then divide by the log of 4, close parentheses, and we get approximately again, it wants the nearest 10,000, so 2.1240 if I round to the nearest 10,000. 2.1240. Alrighty, so now you can do the exact same process for do-it-yourself number 3, A and B, and then we'll go to example 4, which is solving an inequality, which we do much in the same way that we did in the previous lesson. So again, we wanted the log of both sides. So I'm going to get log of 3 to the 5y less than log of 7 to the y minus 2. And what's going to happen is that the entire exponent is going to come out in front and become 5 times y times log 3 less than, in this case, this entire exponent is going to come in front. So you want to keep it together, y minus 2 in parentheses, times log 7. All right? And what we want to do is basically have anything that has a y in it needs to go on the same side of the inequality so you can solve for y, correct? So the first thing we want to do is distribute here. We want to go, this is log 7 times y. So I'm going to go y log 7. And then log 7 times negative 2 is negative 2 log 7. So all I've done there is distribute the log 7 to the y and to the negative 2 as well. And over here I'm just going to have 5y log 3. So now what I want to do is I want to bring this term over to the other side because it has a y in it. The other term doesn't have a y in it, so I don't really care that that can stay there. So this guy needs to come over here. So I'm going to get 5y log 3 minus y log, okay, I'm really sorry about that, but it appears that my pen is running out of battery. And so I need to make a little switcheroo here real quick. And hopefully it won't take us too much time. Let's hope this fixes our problem. Okay, so then we're going to get y, and then we're going to have log 7 less than negative 2 log 7. That seems to work a lot better. Okay, so 5y log 3 minus y log 7 less than negative 2 log 7. Now that they both have a y in common, I can pull the y out, factor basically, and I'm going to be left with 5 log 3 minus log 7, right? So the y, they both have a y, so I pulled it out. I get 5 log 3 minus log 7 less than negative 2 log 7 on this side. And even though this might seem kind of confusing to you, all of the part that's in parentheses is just basically a number. We can type all this into the calculator later. So it's all just a number. So because it's all just a number, we can just divide by that entire thing. 5 log 3 minus log 7 on both sides. 5 log 3 minus log 7. And then that cancels, and you get that y is less than. Now the only thing you have to make sure is that your inequality symbol doesn't need to be switched. Because remember that whenever you divide by a negative, you have to switch that symbol. So I'm going to check what is 5 log 3 minus log 7. That number is positive 1.54. So I do not need to distribute, or sorry, I don't need to switch my symbol. But my answer is going to be negative because it's negative divided by positive. So now what I'm going to do is I'm going to put 2 log 7 and divide that by, I'm going to use parentheses so that I can put this entire thing in parentheses. Be very careful that you need to make sure that you put all of this in parentheses. So I'm going to divide, I already did the 2 log 7, divided by 5 log 3 minus log 7. And I get negative 1 point, and it wants 10,000, so 0.972. Y is less than negative 1.0972. So that would be our solution. So now you can go ahead and try these 2 examples. And then we're going to go to our last example, which is basically what we call the change of base formula. So what happens when you want to change the base? For example, in this example here, they want us to go from log base 3. They want me to know what log base 3 of 20 is. So they want to know 3 to what power is 20. But 3 to no power is going to be exactly 20. So we have to kind of figure out what that's going to be. So I have to be able to put it in the calculator because they want me to round to the nearest 10,000. But my calculator doesn't work in base 3. So what I have to do is change it from a base 3 to a base 10. And so to do that, you need the change of base formula. So here's the formula. If you have a log base a of n, the change of base formula is basically for you to take the new base, so a represents the old base, and b represents the new base. So here I have a quotient that has base b. So you take the new base, log of the new base, of the same number from before, same n, divided by the log of base b of the old base. Okay? So what that means here in example 5, it says express this in terms of common logarithms. So that means they want me to change it from a base 3 to a base 10. So basically, log base 3 of 20 is going to equal log base 10 of 20. Wow, this is horrible. I guess that battery was already bad. So now I need to put in a different battery. And I apologize for this tremendously. I wasn't counting on that when I came to school today. let's try this last battery, if we can just hold off for the next couple of minutes, because we're almost done here. So log base 10 of 20, sorry, that was really ugly. So I have my log of my new base, base 10, of the same number from before, 20, divided by log of my new base, which is base 10, they want a common log, of the old base, so 3. So now I can actually put this in the calculator, and I can even check my answer later. So we're going to say, it also says to give our answer rounded to the nearest 10,000. So log 20 divided by log 3 ends up being approximately 2.7268. So remember that we said earlier is that this is 3 to what power is 20. So what we're saying is that we couldn't figure that out in our head, but now we have the calculator and it's given us 2.7268. So according to this, I can check my answer by going 3 raised to the 2.7268 power, and I get 19.999, which is basically really close to 20. So that assures me that I actually did it correctly. So now if you will do this last do-it-yourself question, you will have completed your notes for this lesson. I will see you in class, and thank you for watching.